All right, so here's video 11, limits, factoring and expanding. We're going to think about this also by trying to input the value. And again, reminding ourselves that limits travel along a curve, and we are looking at how they come from the right hand and the left hand, and at A, and they result in some limit L if it's a continuous function. And again, what we have here today are going to be ones removable or infinite or jump discontinuities. So I thought it'd be easiest to work examples. Again, assuming that you had the instruction, this is the practice side of it. So we'll start here, and I just took some problems that are pretty common. Number 11 is x squared plus x minus 6 over x minus 2 for a function, and they're asking for the limit as x approaches 2. What I want you to recognize immediately is if you plug 2 in here, you get 0 at the bottom. So you can't just direct substitute. And we have two things. We either expand or factor. And you don't need the graph, but I did the factoring here. And I factored the numerator and denominator. And the graph of this is shown here on the xy. And there's a removable discontinuity at 2. And you can see as you approach both ways, it comes down. But we don't need the graph because we can actually do the cancellation and then input the 2, and we can see that the limit is 5. And again, the key here is picturing what's happening. The right hand limit and the left hand limit are equal in this case. And I'm not going to go through this every time, but I want to be clear that this has to happen for the limit to exist. All right? Okay, and again, as you read the problems, you can pause the video, try them yourself, all right? We're going to go right on into number 13 here. There it goes. That green dot was screwing it. So again, we have a function, and this time, when you factor the function, you notice something happens. Nothing cancels, and we can't do this, all right? Even if you want to, you can't do that, okay? And the key here is to realize that that is something that can't happen. If you look at the graph then, because you factored it, can't expand it, can't direct substitute because you put 2 in, it doesn't work, okay? So then you have to picture the graph, or at least check a table. So if you check on each side of 2, you're going to see that you have something very big on the left-hand side, and you have something very small on the right-hand side. And in this case, value the limit. This is D and E. Does not exist. All right? The limit as x approaches 2 from the negative side of this function, it is positive infinity, and the limit as x approaches 2 positive of f of x is negative infinity. And the left hand and the right hand are not the same. So that's the answer. And again, we checked it by factoring or expanding. We tried direct substitution and it didn't work. All right, I'm going to go a little quicker here. For the sake of time, we have 3 more. 15. Again, you plug into the bottom, and negative 3 made the bottom 0. When you plug it into there, the bottom was 0. So you had to either expand or factor. This is factored. And again, I drew the graph, but what happens is t plus 3's do cancel, and that leaves a hole at negative 3. And you can tell as you travel the curve, then the left hand and right hand do work. If you plug this in, then you're going to get negative 6 in the numerator, negative 5 in the denominator. So the answer to number 15 is 6 this. All right. So far, the first 3 have all been, hey, factor them out. The next 2 are the other way, which is you look at this and you have 4 plus h, quantity squared minus 16 over h. You plug 0 into the bottom, and it does not work. So we can do this. I expand the binomial, 4 plus h squared, and I did that right here. And got 16 plus 8h plus h squared. And everyone, I did a graph of this because hopefully you recognize that this is x squared at x equals 4. And if I do that, what we're really doing here is we are pulling this point back to this point. We're taking this secant line between 4 and 4 plus h, and we're making h go to 0, all right? What that looks like for all intents and purposes here is simply this. The limit then changes to this. now h is common. You could factor an h out, and when this h cancels, now we can input it. The answer to this problem is 8. Last one today. And again, you look at that function, you plug 0 into 19 there, and you get over 0, so it doesn't work. You hopefully recognize that this is a function x to the 4th. And it's going from 1 to 1 plus h, so it's taking this secant line, and we're going to find a tangent line by bringing point Q back to point P. What that looks like, though, up here is if you expand 1 plus h to the 4th, and again, you try substitution, it doesn't factor, so we expand it, and you'll see that the non-h's cancel because it was a function, it was x to the 4th. I'm going to skip a step. I am factoring an h and canceling the h as I go here. So I get this, and then all the h's go to 0, and the result of this limit is 4. Again, keep practicing. Limits are practice. Remember, direct substitution, then factor or expand, and then conjugates, which will be another video.